Hello. Today I'm going to present the paper, A Systematic Thinking Design Research Approach Combining the ConOps with Design Scenario, use commercial Cislunar Space Development Project as example to 2020 DMI AD&C conference. Today's presenters is myself, Sheng-Hung from MIT IDM program. My team members are John, Dr. Chaiwoo, Dr. Shabnam, Dr. Joseph, Professor Olivier, and Professor Jonathan. We really appreciate our family, DMI, MIT, MIT Labs, CMU School of Design, and people who fully support and sponsor this research project. Today's presentation is going to break down into 4 chapters: introduction, literature review, case study, and summary and suggestions. This research fused advanced techniques from design research methodology with a systematic thinking approach in order to better illustrate and capture key moments that constitute the specific task of making a moon rover and establishing a solar panel system in micro and macro contexts. This study is valuable in 2 aspects. Firstly, it can improve the existing design research methodology by fusing the ConOps with the design scenario. Secondly, it was a scalable and replicable creative process that experimented with the innovative methodology. Here are the keywords: concept of operations, ConOps, scenario design, design thinking, participatory design. The keywords are all interconnected, interrelated, and represent the essence of the study. Chapter 1, Introduction. The intent of the study was to combine one of the system engineering tools, ConOps, with design scenario. It was an experimental methodology-focused study designed to explore and to resolve the following 2 challenges: how to describe and communicate a complex, multi-dimensional, and multifaceted systematic challenges effectively with the key stakeholders and internal project team in a professional and intuitive way through ConOps and design scenario. How to successfully articulate the intent and present the structure of the project mission through the new experimental methodology. This project demonstrated the process, reflection, and learning of new experimental systematic thinking research approach merged with ConOps and design scenario by prototyping and refining through the commercial Cislunar Space Development Project. Chapter 2, Literature Review. ConOps is one of the system engineering tools to communicate the system blueprint with the key stakeholders and internal project teams, serving the purpose of implementation guidance of a complex project in the early stage of the project development process. ConOps is a tool that is usually applied to solve complex, multidimensional, and multivariable systematic challenges. The diagram here is the ConOps of Max Launch Abort System from NASA. ConOps encapsulates the project mission in a diagram with the estimated time and approximated location of the development, the sequence of each phase, and the highlighted features of the system to reveal the scope of the mission in the qualitative and quantitative way. Design scenario or scenario-based design is not a new concept and has been widely applied to many different fields of research. Some studies mention design scenario needs to reflect the patterns of life, which can echo the lifelike condition. Others researchers argue that scenarios could provide an explicit guidance and clear vision to inform how a technology can be applied and supported. Still, other studies gave its definition as emphasizing on viewing user as an abstractive role and describing the ways how users achieve the goal of the task. Let's move on to Chapter 3, Case Study. The case study, the Commercial Cislunar Space Development Project, was part of the 3-month system engineering project designed for a 2020 RASCO competition under the theme of the business innovation, managed by the National Institute of Aerospace, NIA, and NASA. According to the definition from Raskol, cislunar space consists of the spherical volume of space with its radius defined by distance between the Earth and Moon. It represents a prime environment for future business opportunities to improve life on Earth through the use of space. The project was designed to explore the potential business model and strategy that was to expand the economic sphere beyond the Earth's surface. The study applied the selected design thinking approaches and system engineering methodology to generate the concepts of the lunar energy grid that would empower NASA's future mission in space. The project accomplished the allocation and derivation of energy system and its subsystems, a defined system ConOps, an identity stakeholders map, a design OPN, and OPN stands for Object Process Methodology, and preliminary design architectures. However, this study focused on demonstrating the innovative process to combine ConOps with design scenario. So basically, the image you see in this slide, it's kind of like the ideas of the final concepts. So let's look at the design process. Step 1, clarify the mission. Before entering the mode of creating ConOps, the project team needs to know the goal of the mission. Was the project intended to collect material and data from the moon or establish the sustainable business around the moon and the Earth? The answer is to build the solar power energy transmission system in this study. The clarified project mission set a cornerstone for accelerating the rest of the process. The blue dot in figure 3 indicate the project's end goal. Step 2, identify the key phases. Once the project goal was well established and clarified, the next question was how to achieve the project goal by breaking it down into key phases. It needed to take the critical elements, including estimated launch, travel, arrival time, resources, and approximate location into consideration, and arrange these key phases in sequence. The project also needed to evaluate the backup plan in case of other unpredictable factors. Figure 4 demonstrated the simplified version with 4 phases to achieve the project goal. Let's move on to step 3, visualize the concept. With a clear goal and key phases all set, the next step for the project was to connect all the key phases together in sequence by visualizing the journey of the project. What could be the possible scenario in each key phase, including 3 recommended criteria to evaluate: the who, the where, and the what, to help envision the future scenario. The green boxes shown in figure 5 were the space for scenario visualizing connected to the phase accordingly. It was an innovative part of the process by adding a design scenario tool to the ConOps. It needed not only to reconsider the scope of the project in terms of the time frame, the logistics, and location in the mission, but also to take people's interaction, behavior, and extreme environment condition, the relevant equipment, and other elements into detailed consideration. A format to interpret ConOps, scenario visualization was an important and powerful tool to efficiently improve the internal communication with ease and at a low cost. The case study presented in the selected phases by illustrating the key components. You can see this image, figure 6, including spacecraft, 3 types of rovers, astronaut, and integrating them into the ConOps. Step 4, map out design scenario connected with key phases in ConOps. Step 4 was the highlight of the process. By connecting the design scenario with the key phases in the ConOps served to illustrate the overall mission in terms of the structure and the sequence, whereas the design scenario was to play a significant role in forecasting the possibility of the future condition and interaction between people like astronaut, environment and objects like equipment and spacecraft in early key phase. Design scenario was a helpful creative tool for internal team and key stakeholders to utilize in the mission. The simplified diagram presented in Figure 7 conveyed the concept and the relationship of ConOps, key phases, and design scenarios. The following 3 images were selected from the commercial Cislunar space development project to present the ideas of using ConOps as the main backbone structure and adding design scenario to each stage in the project. This is Day 5 scenario, deployment of Type 2 3D printed rover. This is Day 10 scenario, deploying solar panel using Type 1 transport rover. Our last chapter, summary and suggestions. Here are some key learnings and reflection. First point, task-driven approach and context-driven process. ConOps was used as a tool to convey the project's mission and its scope to the key stakeholders and internal team. In the lens of the structure of the mission, ConOps was the tool featured with the linear yet time-dependent process driven by specific project tasks that derive from separating the goal of the mission. Whereas the design scenario was the context-driven tools which greatly illustrated the interaction between people's behavior, equipment, and environment within each key phase of ConOps in the project. A design scenario tool served the purpose of composing a series of storyboards to bring ConOps to life by zooming in each key phase through visualize and description of the scenarios. Table 1 shown above is the comparison of 2 tools in principle level. The second point, structure-based planning tool and concept-oriented action. ConOps provide a structure-based planning tool in order to reasonably assign the right sequence of each scientific task in every key phase, whereas the design scenario was a concept-oriented action. A design scenario tool was composed of many curated design concepts to help envision the possible future setting, which raised the key question. How did the environment is about where, people's behavior is more about who, and equipment is more about what interact? The last point, challenges of ConOps explanation. In most cases, successfully articulating the intent and present the structure of the project mission merely through ConOps is still a bit difficult. There are 2 aspects to understand the difficulties. The first one, information level and fidelity. How to present the right level of information with the proper extent of fidelity within the reasonable scope of the project to the audience without information overloading and distraction. The second one, the use of language. How to use the precise and clear language to describe the key phases of the mission, the process, the condition, without overused jargon has become increasingly important. About the next step of the project. The first one, integrated design scenario with ConOps. In the context of the project, ConOps was viewed as a systematic mapping tool to define the various key phases of the mission. A design scenario tool is like a muscle to support the skeletal structure of the ConOps. Take the commercial Cislunar space development project as example. By integrating design scenario into ConOps, it made the overall ConOps diagram informative and the concepts and scenarios easy to relate and to understand. The second one, establish design principle to use graphic. For further study or further research, the key component to successfully integrate ConOps and design scenarios is applying the graphic and all relevant visuals properly to both tools. The graphic stands for not only scenario illustrating, but also a type of visual language to assist in simplifying the content and increasing the efficiency of internal communication. Therefore, establishing a set of design principles for applying the graphic to ConOps and design scenarios was invaluable for the next step of the study. So this is our presentation. Thank you for listening. Hope to see you all soon. Thank you.